In this problem, we're looking at a stone falling from a cliff, which means that it's subject to g, the gravitational acceleration of 9.81 meters per second squared. Now, this acceleration is presumed constant, with assuming no air resistance. So I have taken the time to write out the three equations of motion that we tend to use for situations of constant acceleration. Now, we're told that a stone is dropped from a cliff and lands after a time of 3.55 seconds. And we want to find the height of the cliff. So what this is basically asking is how far the stone travels down, assuming it's dropped from the top of the cliff. So since we're assuming constant acceleration, we'll want to use one of these three equations here. So the first step is to choose which one. Now, again, we'll want to choose one that has the variables we're given, as well as the one we're trying to find. So we're not going to consider this first equation because it makes no mention of displacement or a change in height. So that one's irrelevant. And this third one is as well, since one of the variables we're given is the time period, and this equation doesn't include t. So we have to use this second one, the one that states that the displacement is equal to the initial speed times time plus half of the acceleration times t squared. I'm going to correct that real quick. There we go. Now we can simplify this equation a little bit for our personal use, because one thing to note is that the initial velocity, v naught, is going to be 0. And we can assume this from the way the problem is set up. It says the stone is dropped from the top of a cliff. Not thrown or projected, it's just dropped, which we assume means it starts from rest. So if v naught is equal to 0, then this whole term is 0 and can just be ignored. So 0 plus, or you don't even need to write that part really, the displacement is equal to 1/2 times the acceleration. And as we talked about earlier, that acceleration has a magnitude of g, 9.81 meters per second squared. And that is times the square of time. Now really, all that we need to do at this point is just plug this into our calculator. 1/2 g t squared, where g is 9.81 and t is 3.55. So if we plug this into our calculator, then we find a displacement of about 61.8 meters. So this is the distance through which the stone falls, which means that this is the height of the cliff. So that is our solution to the problem. I hope this video helped you out. If you have any questions, please leave a comment down below. And if you'd like to have a further dialogue, or if you'd like to make a request for a future video, I have a Discord server linked in the description below, where all are welcome to join and talk about whatever they wish. That is all for this video, and I hope you have a good night. Bye-bye.